We physicists have waited 100 years since 1916 for this photograph.
Throughout history, humanity has constantly searched for answers to the mysteries of the universe. In 2021, we launched the James Webb Space, and it is now silently observing the vast expanse and capturing awe-inspiring images. These images have the power to redefine our understanding of the cosmos. However, a recent revelation from the Webb Telescope has sent shockwaves through the scientific community as it has discovered a gap in the universe that defies the laws of physics and challenges our very concept of reality. Even expert astrophysicists are left with a spine-tingling sensation. This discovery threatens to dismantle our existing comprehension of the universe. Let's delve into the details of this groundbreaking discovery that has left scientists shocked. Since its launch, the James Webb Space Telescope began a monumental mission driven by our shared curiosity and desire as a human race to unlock the secrets of the cosmos. With its colossal primary mirror, 3 times the size of Hubble's, this telescope possesses an unmatched ability to capture the faintest traces of light emanating from the farthest corners of the universe. Recently, the James Webb Space Telescope has made an extraordinary discovery. Astronomers using the telescope have identified the earliest known black hole in the universe, suggesting that there might have been countless others that existed even earlier. This supermassive black hole, located at the heart of a young galaxy, was detected approximately 570 million years after the universe came into existence. It possesses a mass 10 million times of that of our Sun. However, this black hole is likely just one among many that existed during the cosmic dawn, a period that occurred around 100 million years after the Big Bang, when the universe emitted a radiant glow for a billion years. Scientists are uncertain about the reasons behind the abundance of these black holes and how they grew to such colossal sizes. The research team responsible for this discovery shared their findings on the preprint server archive, although the research has yet to undergo peer review. Rebecca Larson, the lead author of the study and an astrophysicist from the University of Texas at Austin, explains that while this is the first black hole found at this particular point in time after the Big Bang, many more are expected to be discovered. She believes that there are younger black holes that formed earlier in the universe's history, and with the advent of the James Webb Space Telescope, scientists will have the opportunity to study this era more extensively and unveil additional black holes. Black holes come into existence when massive stars collapse and continue to grow by consuming gas, dust, stars, and even other black holes. In some cases, the material spiraling into these voracious cosmic entities become heated due to friction, resulting in the emission of light that telescopes can detect. These black holes, known as active galactic nuclei of AGN, can produce quasars, which are the most extreme form of AGN. Quasars are supermassive black holes billions of times heavier than our Sun and emit light blasts trillions of times brighter than the brightest stars. As light travels through the vacuum of space at a fixed speed, scientists can look deeper into the universe and observe events that occurred farther back in time. To spot the black hole in question, astronomers employed 2 infrared cameras on the James Webb Space Telescope, the mid-infrared instrument, MIRI, and the near-infrared camera. These cameras utilize built-in spectrographs to break down the light into its component frequencies. By analyzing the faint glimmers of light from the universe's early stages, researchers identified a distinct spike in the frequencies, indicating the presence of faint radiation emitted by hot material surrounding a black hole. The mystery of how black holes formed so rapidly in the young cosmos remains unsolved. Astronomers continue their quest to find even younger black holes, known as primordial black holes, which are believed to have originated shortly after, or even before, the Big Bang. However, such black holes have proven elusive thus far. There are 2 prevailing theories that explain the rapid growth of black holes after the Big Bang. One theory suggests that they are remnants of giant stars that form much more quickly than the stars we observe today. Another theory proposes that dense clouds of gas collapse suddenly, giving rise to these devouring singularities in space-time. Larson suggests that the observed black hole is likely the result of a population 3 star, an early type of star composed primarily of hydrogen and helium. This star would have exploded around 200 million years after the Big Bang, leaving behind a black hole. The black hole subsequently accreted a substantial amount of material at an accelerated rate, leading to its observed size. Moving forward, the researchers plan to collaborate with the team responsible for building MIRI to search for an even stronger signature of light from a distant galaxy. This additional data could offer further insights into how this enigmatic black hole formed at the center of the galaxy. The discovery of this ancient black hole marks a significant milestone in our understanding of the early universe. In recent weeks, the James Webb Telescope has made numerous astounding discoveries by capturing images of the early universe. One of the recent images captured by the James Webb Telescope shows us a spiral galaxy called NGC 7496. It's a captivating sight, with wispy threads of gas and dust weaving through large empty spaces, all shaped by young and energetic stars. This image isn't just eye candy, it's also packed with valuable scientific information. Using the JWST's impressive resolution and sensitivity, astronomers have identified 67 potential star clusters within NGC 7496. This galaxy is located about 24 million light-years away in the Grus constellation. According to NASA, these clusters could contain some of the youngest stars in the whole galaxy. NGC 7496 is just one of the 19 galaxies that the JWST has been studying as part of a collaborative project called FANGS, or Physics at High Angular Resolution in Nearby Galaxies. This project combines observations from various telescopes, including JWST, ALMA, MUSE, Hubble, and the VLT. Its goal is to gain a better understanding of how interstellar gas and star formation contribute to the structure and evolution of galaxies. The JWST's infrared vision plays a crucial role in this project. It can see through the gas and dust that often surrounds newly formed stars, which are usually invisible in optical wavelengths. To achieve this, the telescope uses a special instrument called MIRI that is sensitive to infrared light ranging from 5 to 28 microns. Previous studies of star nurseries using infrared were limited to our own Milky Way, the Magellanic Clouds, and nearby galaxies in the local group. This was mainly because older telescopes lacked the necessary power to explore deeper into space. However, the JWST's enormous 21-foot primary mirror changes everything. It allows us to peer much further into the space than ever before, revealing sights that were unimaginable just a few years ago. During a recent survey of a quiet area in the sky, James Webb made another groundbreaking discovery. This region was important because it showed visible traces of radiation from the early universe, offering glimpses into what happened right after the Big Bang. In the midst of the quietness of space, the telescope detected a faint light, a small signal in the vast dark emptiness that is in space. It turned out that this faint light originated from a galaxy located at the very edge of our observable universe. This galaxy existed so long ago and so far away that its light has traveled for billions of years to reach us. According to NASA scientists, this discovery is like finding a time capsule, providing a glimpse into the era when the first stars began to form. However, what alarmed and intrigued scientists the most was the peculiar movement of this distant galaxy. Its motion defied our current understanding of celestial bodies in space. It was as if an invisible force was exerting influence, a concept we had not previously contemplated. Immediately, NASA scientists began to pose numerous questions and explore a wide range of possibilities. Could mysterious dark matter be responsible for this peculiar motion? Or is there an entirely unknown enigmatic presence in the cosmos that we have yet to identify? The finding of this distant galaxy and its puzzling movement has opened up a whole new realm of questions and discussions. It reminds us how much we still have to learn about the universe. Some space experts find it both humbling and exciting to realize that these groundbreaking discoveries are pushing us into a new era of exploring space. This particular section of the galaxy has unexpectedly sparked a flurry of activity among scientists worldwide. Researchers from all over the globe are eagerly trying to decode the hidden messages contained in the ancient light from this faraway past. It has become a race against time as scientists work tirelessly to unravel the existing clues and understand the true nature of the invisible force that seems to be affecting the path of this galaxy. According to experts, every piece of information we gather from this discovery brings us closer to understanding the universe, its origins, movements, and what might happen to it in the future. NASA's James Webb Telescope has captured images of a mysterious planet as we venture further into space. Scientists at NASA, guided by the remarkable vision of James Webb, emphasize the importance of taking a moment to appreciate this astounding discovery that has come our way. The James Webb Space Telescope is not just a successor to the famous Hubble Space Telescope. It represents a monumental leap in our ability to explore space. With its advanced scientific tools and a massive 6.5-meter main mirror, the JWS allows us to delve into the universe in ways we have never been able to before. It uncovers the mysteries of the universe's early days. One of the most captivating features of this telescope is its incredible ability to detect infrared light. This capability allows it to see through dust clouds where new stars are born, observe galaxies formed shortly after the Big Bang, and even analyze the atmospheres of distant planets for possible signs of life. This ability to detect infrared light led to the chilling discovery we recently made. The Mid-Infrared Instrument, or MIRI, on the JWST played a crucial role in this significant discovery. NASA states that MIRI offers unparalleled sensitivity and clarity in the mid to long infrared range, which is crucial for studying objects in the far reaches of the universe. This heightened sensitivity was vital in detecting the chilling signals coming from the edge of the universe. That means we have enough supplies and equipment on the telescope to last for 10 years. The observations made by the James Webb Telescope are really interesting, as they're not as straightforward as we might think. The universe is huge and constantly changing, and the light we receive from galaxies that are billions of light years away has traveled incredible distances and spans billions of years. So, when we look at this light, we're actually looking back in time and seeing the universe as it was when this light was first emitted. It's like having a time machine that lets us study the early history of the universe. The James Webb Space Telescope has captured a snapshot of this early universe, which is pretty amazing. Another fascinating thing is gravitational lensing. It's a phenomenon predicted by Albert Einstein's theory of relativity, and it explains how big objects in space can bend the path of light that passes near them. It's like a cosmic twist that distorts the light as it travels. The James Webb Space Telescope takes advantage of this phenomenon and uses it as a natural magnifying glass to look even deeper into distant galaxies. By studying the light that's magnified and distorted by closer massive objects, the telescope can reveal hidden details that we wouldn't be able to see otherwise. Even with all the incredible capabilities of the James Webb Space Telescope, scientists still wonder what lies beyond its reach. Could there be more mysterious and exciting things in wait at the edge of the universe? These unanswered questions continue to fuel scientists' curiosity and tease them with their secrets. We'll have to wait and see what the future brings as the telescope keeps exploring the vastness of space in search of answers. Experts now say that thinking about our place in this enormous cosmos is truly humbling. Even though we're just a tiny blue planet floating in a ray of sunlight, we have the ability to make astonishing discoveries. With each new finding, we come closer to understanding the grand canvas of the universe and reflecting on our role within it. Every star and galaxy we observe reminds us of our cosmic journey and the endless possibilities for exploration. The James Webb Space Telescope gives us a front row seat to witness the unfolding cosmic drama from the edge of what we can see. It's interesting to speculate about the behavior and movements of distant galaxies. Some theories suggest that the mysterious dark matter, which exists in the unexplored outer reaches of the universe, could be responsible for these strange movements. Dark matter is an unseen substance that reveals itself only through its gravitational pull. It's believed to make up a huge 25% of the entire universe, far overshadowing everything we can actually see, like galaxies, stars, and planets. It's actually quite shocking that we still don't know much about the majority of the universe. Our understanding of dark matter has eluded us for a long time, ever since astronomer Fritz Zwicky proposed its existence back in 1933. Despite its significant presence in the cosmos, we haven't been able to directly detect dark matter. Scientists have long believed that the expansion of the universe would eventually slow down. But when NASA's Hubble telescope observed the cosmos, it found something unexpected. The universe was actually expanding at an accelerated pace, leaving astrophysicists puzzled and searching for answers. After a lot of thinking, scientists reached a stunning conclusion. They determined that a whopping 95% of the universe is made up of dark matter and dark energy, which are invisible phenomena but have a real impact on the visible world. Although the James Webb Space Telescope can't directly observe dark matter, experts believe it can decipher its effects on the surrounding cosmos and uncover the universe's deepest secrets. Astrophysicists who study dark matter have been really excited about the James Webb Space Telescope ever since it launched. This telescope has some awesome technology that allows it to do cool things with light from faraway galaxies. It can use a process called gravitational lensing to bend the light, which helps capture amazing images of these galaxies we've never seen before. It does this by taking advantage of the massive galaxies that are closer to us. By taking pictures of these distant galaxies, the JWST has helped scientists figure out how much mass those closer galaxies have. They do this by measuring how much the light from the background galaxies gets bent and comparing it to what they predicted for the mass of the closer galaxies. But here's what's even more interesting. The JWST has recently detected galaxies that existed 13 billion years ago, and scientists have also used advanced computer simulations to study the early universe. This has given us new insights into dark matter. So, the widely accepted theory was that dark matter was made up of stuff that doesn't move much and only interacts with gravity. It's called cold dark matter. But now, researchers are considering other possibilities to explain some issues with the standard theory, especially on small scales. These new ideas suggest that dark matter could be made up of particles that move a bit faster and have a small amount of heat, which is called warm dark matter. Dr. Umberto Michio, who works at the Italian National Institute of Astrophysics, has been studying dark matter and recently published a paper on it. He thinks that the JWST's recent discoveries of galaxies from the early universe are really important. According to him, these findings give us the valuable insights into what dark matter is like. In their study, they rule out dark matter models where the particles have mass of 20 kiloelectron-volts, keV, or less. They found that dark matter is mostly made up of cold or mildly warm particles that have masses greater than this limit. This study has used data from much earlier times and advanced computer simulations to improve our understanding of the matter in the universe. Previous studies had a hard time telling the difference between different dark matter theories. However, by analyzing recent data and using the JWST's observations along with new computer simulations, researchers have made significant progress. They were able to study statistical patterns in ancient galaxies and successfully distinguish between different models of dark matter. Dr. Umberto explained that their focus was on the visible characteristics of structures that formed in the universe when the first stars and galaxies were born. The type of dark matter particles affected how these cosmic objects formed. In their study, they found that different dark matter models showed variations in things like how stars form, how bright they are in ultraviolet light, and the amounts of certain molecules. By using the latest data from the JWST, they were able to compare and identify these differences between the models. This research is really groundbreaking because it uses data from the earliest periods of the universe and helps us narrow down our understanding of dark matter. The JWST has given us the amazing opportunity to observe galaxies that are incredibly far away in the universe. This has provided us with valuable information about what these galaxies are made of. In the future, as we gather more data, especially from smaller, fainter, and younger sources, scientists believe that we will learn even more about the early formation of stars and the gases, like carbon monoxide, emitted by galaxies. NASA has recently announced a major breakthrough: the discovery of ancient galaxies by the Webb Telescope. This discovery shows us that these galaxies formed in a surprisingly short period of time, less than 1 billion years ago. When we think about how vast the universe is, this time frame is incredibly brief. Because of this exciting progress, we can expect to find more galaxies that were formed in the early stages of the universe in the coming years. This will deepen our understanding of the fundamental blocks of matter and contribute to further scientific advancements. Scientists envision a future filled with a wealth of data as the JWST continues to uncover the hidden mysteries of the cosmos. The telescope will focus on smaller, fainter, and younger celestial objects, shedding light on the secrets of the past. These upcoming observations promise to reveal more puzzles and provide additional clues about how stars formed in the early universe, bringing us closer to understanding the mysterious nature of matter itself. Scientists are confident that this will lead to a profound understanding of the universe and our place in it. Thank you for joining us on another episode of Voyager. While you're still here, don't forget to click on the video on your screen for more high-quality content. So, that seems enough for this video. Let us know your thoughts in the comment section and stay tuned for more videos.